In this video, we're going to review equilibrium of a 2-force or 3-force body. The objective will be construct a force triangle through the vector addition of 3 forces and apply the principle of concurrent forces in static problem. Recall principle of concurrent forces. It only applies when there are 2 or 3 forces. Only the line of action, the line along which a force acts of the forces, needs to pass through the common point, not the forces themselves. And it does not apply when all forces act in the same direction, since the lines of action of the forces will never intersect. Now let's look at the problems together. Consider the arc-shaped playground structure shown below. Assume that the weight of the structure can be ignored. There are pin connections at A, B, and C. A child is pulling down on the structure at D and exerts a downward force of 250 newtons. For the loading shown, in what direction is the reaction at C? Does your answer depend on the loading that is applied to the left half of the structure? Why or why not? Does your answer depend on the details of the shape of the member BC? Why or why not? In what direction is the reaction at A? Feel free to pause the video and solve the questions on your own. Now let's look at the first one together. For the loading shown, in what direction is the reaction at C? We will now look at the right piece of the structure. There is a pin connection at point B, therefore it will result a horizontal and vertical force, which will result a diagonal force at point B. And at point C, it is also a pin connection, which will result the same as point B. As we drew in the diagram below, this will be a 2-force body. Therefore, the reaction at C and at B must act along the line BC, which makes the last one the correct answer. Now, let's look at the next one. Does your answer depend on the loading that is applied to the left half of the structure? Why or why not? Since we're considered BC as a 2-force member, therefore the reaction direction will always act along BC. However, if there's any changes happen in the left part of the structure, for example, if the force applied to point D changes, it will also change in the equilibrium equation. Therefore, the magnitude of the force at C might also change due to the change in D. Therefore, the answer will be no, the magnitude of the force at C may change, but the reaction direction of C does not change. Next, does your answer depend on the details of the shape of the member BC? Why or why not? Now, let's look at the picture shown below. Since BC is considered as a 2-force body, no matter how the shape changes, the reaction direction will always be along the line BC. This makes no, the 2-force body argument still holds regardless of the shape of the member, true. Lastly, in what direction is the reaction at A? Consider the graphical representation of the left piece of the structure shown below. The left part AB can be treated as a 3-force member, and we can simply draw a force triangle as shown here. And we can easily find the direction of reaction at A. Therefore, the correct answer will be treat AB as a 3-force member and use the principle of concurrent forces to find the direction of the reaction at A. And in summary, Here are all the answers for the questions. That's it for the video.